Very welcome to the Kisan Quantum Mechanics. And today we are going to learn about the quantum mechanics. So first see the words of quantum mechanics. So here we learn about the quantum mechanics. Magnetic phenomena which constitute classical physics. However, that is not enough. You wish to go deep into physics. And your question will be why? The answer is that classical physics on its own cannot explain many natural observed phenomena. Hence, there seems to be a need of a wave-particle duality. You know several courses in physics, from elementary mechanics to electric and magnetic phenomena, which constitute classical physics. However, that is not enough. You wish to go deep into physics. And your question will be why? The answer is that classical physics on its own cannot explain many natural observed phenomena. Hence, there seems to be a need of a new physics. And here we will dwell briefly on some phenomena and experimental results which defy classical analysis. Now we will introduce you to quantum postulate of Planck's, which was given to explain the experimental result of the black body radiation. It was further extended by Einstein and Bohr to explain the phenomenon of photoelectric emission and line spectra of atoms, respectively. The sequence of events is chosen to give you an idea of how quantum physics came into being. Then we discuss one of the basic concepts which laid down the foundation of quantum mechanics, namely the wave-particle duality. So here is the objective of this course. After studying this, you will be able to discuss how quantum physics emerged, calculate the de Broglie wavelength of a particle in motion, and explain the concept of wave-particle duality. So first see the worth of quantum physics. We already know that a black body absorbs all radiation which fall on it, since it does not reflect light and appears black. Hence the name black body is given. Usually in the laboratory experiments, a hollow body cavity with blackened walls and having a small hole acts as a black body. The radiation contained in the body and emitted from the hole produces a black body spectrum. In the last century, a number of experiments were carried out to measure the energy per unit volume contained by a black body, denoted by rho sub t lambda as a function of lambda at different temperatures. Some of the representative curves showing the variation rho sub t as a function of lambda black body spectrum at different temperature. Various investigators try to explain the nature of these curves using well-established laws of classical physics, including thermodynamics and statistical mechanics. That it was Planck who come up with a theoretical explanation of the black body radiation curve. We know that till 1900, most of the measurements of energy spectrum of black body radiation were made at a smaller wavelengths. This could be satisfactorily explained by Lenz's formula given by rho sub t d lambda equals to a lambda to the power minus 5 exponential under bracket minus b by lambda kt d lambda, where a and b were adjustable parameters. Planck found experimentally that by the replacement of exponential open braces minus b by lambda kt by exponential minus of power open braces b by lambda kt minus 1. A set of parameters a and b could be obtained, which would fit the obtained curve beautifully with the experimental data over all values of lambda. However, he found it extremely difficult to give a theoretical justification for the above mentioned replacement. Ultimately, out of the this separation, on 18th December 1900, Planck declared that the only way to derive the correct black body radiation formula was to postulate that the exchange of energy between matter, that is bulbs, and radiation cavity could take place only in a bundles of certain size. To realize the significance of the above postulate, let us consider the following simple example. Suppose the 2 liters of milk is to be distributed between 2 persons. In how many ways can you distribute this milk? So, milk is an infinitely divisible quantity. Hence, you can divide milk between 2 persons in an infinite number of ways. Now, suppose you are restricted to distribute milk only in the units of liter. Now, the number of distribution reduces just to 3. Both persons can receive only 0, 1 or 2 liters of milk. What a drastic change. The number of ways will increase to 5 if you reduce the unit to a half a liter. In classical physics, energy is regarded as an infinitely divisible quantity. Hence, the exchange of energy between the bars and cavity can take place in an infinite number of ways. However, through his postulate, Planck reduced the number of ways to be finite. In this model, the exchange must take place in the unit of U sub 0. Thus, he introduced the idea of discreteness in the division of energy, which was thought to be infinitely divisible. If the energy cap U, which is the function of lambda, that is U lambda, is to be exchanged, U lambda by U sub 0 must be an integer. If not, it is not. Planck suggests that it should be an integer close to U lambda by U0. Planck further postulated that the unit of the quantum energy U sub 0 is directly proportional to its frequency, that is U sub 0 equals to h nu. The constant of proportionality h is known as Planck's constant. In his honor, its value 6.62618 into 10 to the power minus 34 joule second. Planck was awarded the Nobel Prize for Physics in 1918 for this work on the black body radiation. You should note that the greater the value of nu, higher will be the value of quantum of energy U sub 0, and consequently lesser will be the number of ways in which U can be exchanged. This new concept of Planck's gave birth to a new physics known as quantum physics. Hence, it is appropriate to take 18th December 1900 as the date of birth of quantum physics, which later on developed into quantum mechanics. In the further development, Einstein used Planck's quantum hypothesis to successfully explain the photoelectric effect. So, we see the photoelectric effect.
So you learn about the birth of quantum mechanics, and these all videos are promoted and financed by Movie Research Center, International Movie Research Center. So thank you very much buying this quantum mechanics by Quantum Kisan.